Hello guys, this is Srinivas, the developer from the developer channel. Today we are going to solve the SKIDMARK daily challenge of 14 July 2021. Here this is the problem they have given. Like they will give a integer n. We just need to print the third bit from the last, which is nothing but uh third bit from the last of the given number. We just need to get the bit from binary representation of the given number. They have mentioned that the number is always greater than 4, so we don't have to worry about the lesser cases. So here they have given the input 10. So if we represent the 10 as a what binary value, we will get 0. Okay, let me write the what binary table here. uh, 1 2 4 8 16 32 64 128 and so on. So we have 10, right? If we split the 10 value into binary forms, we don't have 1 in 10, but we have 2 in 10. So we put 1 here, and we don't have 1, right? So we put 0 here. We don't have 4 in 10, but we have 10 minus 2 will give you 8, right? So we put 1 here. Everything will be 0. So the third bit from the last is this one. So this is the output we have obtained here for the value 10. So this is nothing but for 10. Output gives is 0. Likewise, they have represent 12 here. For the value of 12, we don't have any 1 in 12. So we put 0 there. But we have 2. But 4 plus 8 will make. So we can represent this value in this manner. So it will be quite easy to understand. Like we don't have any 16 in 12, but we have 8 in 12. So we put 1 here. So 12 minus 8 will give you 4. We have 4 in 12, so we will get 1 here. We don't have any 0 because 12 minus 8 will give you 4. 4 minus 4 will give you 0. So now we have 0 in our hand. So we don't have any 2 or 1. So we put 0 and 0 here. This is the binary representation of 12. So the third bit from the last is 1. So the output is 1. So this is the logic behind this problem. So let me share how we are going to solve this. So we can get we can just remove the bit one by one using the shifting operation. So if we put left shift, it will add 0 here. So the shift will be increased. So if we add right shift here, so it will remove the last digit. If we doing the right shift operation for 1010, so right shift of 0 doesn't do anything. So if we shift the value by 1, so this will be removed. We will get 1 0 1. So every shifting will give you 0 in front of them. If we again do the shifting operation for this value, this is first shift. and for second shift. So if we do the second shifting operation, so this one will be removed. We will get 0 0 1 0. So we have removed first digit, second digit, and third. We are in the third digit, right? So we just need this one. So to obtain this one, we can do AND operation, which is nothing but multiplication. So if we do that for 0 0 1 0, and we are adding 1 at the last, this is a add up operation. So we'll give you, we just need to multiply for the add operation, and we just need to add for the XOR operation, which is nothing but multiplication. So 0 into 1 will give you 0. This thing will be remain the same. So 1 0 0. But it does, sorry, adding 1 means these things will be 0 0 0 0 1. So it will give you 0 0 0 0, which is nothing but a whole value of 0. So if we do the same operation for 12, first we will get 1 1 0 0, and after uh, right shifting we will get 1 1 0. The last 0 will be removed. So after one more right shifting we will get 1 1. That's it. So if we do the AND operation for this value, we will do something like this. We just need to multiply for the plus and add for the dot, which is nothing but a multiplication. So if we do that, 1 into 1 will give you 1, and 1 into 0 will give you 0. As the whole value, we will get, if we put the value here, we got 1. 1 is the whole representation of this value. So this is how we can get the nth digit. So if we want to get the nth digit from the last, we just need to do n minus 1 right shift operation. And finally, to get the unit digit, we have to get the what? We have to add the add operation with 1. That's the thing or prerequisite to solve this program. Let's see how we are doing this in a programmatical way. Here they have given a code like this. Oh, that's a coincidence. They are also using the right shift operation and add operation. Wow, that's great. So what we have just need to do is we just need to shift the n value, which is nothing but the given input, by we just need the last 3 digit, right? Sorry, last third digit, right? So 3 minus 1 give you 2. So we just need to shift by 2. And finally, to get the unit digit, we need to do the AND operation by 1. So if we save and run this program, I am passing the value 1 5. So the binary representation of 15 will give you something like this, I guess. We don't have any 16 in 15, so it will 0 here. We have 8 in 15, so put 1 here. 15 minus 8 will give you 7. We have 4 in 15. So put 1 here. 7 minus 4 will give you 3. So we have 2 in 3. So put 1 here. 3 minus 2 will give you 1. We have 1 here. So put 1 here. This is nothing but the binary representation of 15. So if we shift the values by 2, we will get rid of all those 2 digits. Finally, we skip here. So if we do the AND operation, it will return the value like 0 and 1 will give you 1. This is how we get 1 here. That's it, guys. Here, this is the code for your view. Hope we will meet soon with something else tomorrow. Until then, bye.